Alrighty, welcome everyone to day 12 of Advent to Code. Problems in a few seconds. Code is all ready. We're in the right problem. Fingers crossed today is not too hard and goes pretty easy. Let's see, day 12, let's do it. You finally reached the hot springs. You can see the steam rising in secluded areas attached to the primary ornate building. As you turn to enter, the researcher stops you. Wait, I thought you were looking for hot springs, weren't you? You indicate that this definitely looks like hot springs to you. Sorry, common mistake. This is actually the onset. The hot springs are next door. You look in the direction the researcher's pointing, so you notice a massive metal helix towering overhead. This way. It takes only a few more steps to reach the main gate of the massive fenced-off area. To the springs, you go through the gate and into the small administrative building. About springs, we're having a lava storage at the moment. You ask about the missing machine parts to this island. Oh, all of your island is currently offline. Nothing is being manufactured at the moment, not until we get more lava to heat our forges. And on in our springs, the springs aren't very springy unless they're hot. So as you go up to see why lava stopped flowing. The springs are too cold for normal operation, but you should be able to find a springy one enough to launch you up there. There's one problem. Many of the springs have fallen into disappear, so they're not actually sure which of the springs is even safe to use. Condition records of the springs are damaged. You need to help repair them with the damaged records. In the giant field just outside, the springs are arranged into rows. For each row, the condition records show every spring and whether it is operational, damaged, or operational or damaged. This is the part where the conditional records that is itself damaged for some springs is simply unknown. Damaged or operational. However, the engineer that produced the condition records also duplicated some of his information in different formats. After the list of springs for a given row, the size of each contiguous group of damaged springs is listed in the order those groups appear in the row. What? After the list of springs for a given row, the size of each contiguous group of damaged springs is listed. Oh, it's like a checksum. This list always accounts for every damaged spring, and each number is the entire size of its contiguous group. With no unknown spring conditions, it might look like this. Okay. Is your job to figure out how many different arrangements of operational and broken springs even fit in the given criteria in each row. One way to separate groups of 1, 1, and 3 broken springs. For each row, counts all the different arrangements of operational. I feel like okay. I don't actually know how to approach this one. Oh. Which is not a good sign. Alright, so I don't know where I left off. I also don't know how I'm quite editing this. Short story short. I actually went through and I did complete part 1, and my initial solution, which is this, doesn't work for part 2. Well, it does, but it's just way too slow. And like I probably would take days to solve. So originally I had done all this work and like a normal video, and I actually decided to end the video there at part 1, claiming I couldn't do part 2. Then my brain decided it would not let this go, and actually ended up rewriting it to be this method here, which you can see here works, but is very slow, just not nearly as slow as the other one. It takes like 10-ish minutes. I don't know, we'll kind of see how this goes. It's slow, just not as slow. So I did actually end up getting both parts, but because of that, there's not a traditional video in the sense that I'm probably not going to show you how I coded the first part, which is up here still. I'll probably delete it soon, because again, it didn't matter because it gets scrapped anyways for my new solution, which I didn't record because again I'd stopped it because of, yeah. So long story short, yeah, it was the day 12 was kind of a disaster. So what I'm doing now is I'm going to go back and I'm going to explain the code here so that you can see it, and explain the final solution I went with, as I can delete this now. Explain to you how it works, and we can go from there. So day 12, as I bring it back up, basically we are given these inputs that have a pattern and question marks, which we don't exactly know what goes there. Our the second half of each line has the number of pound symbols and their kind of ordering, or the grouping of those pound symbols. So essentially what we're doing is we're building up all of the possible solutions to the pattern given the groupings that satisfy the given sequence of string, or the given string sequence with the question marks in it. That can be kind of anything. The way I ended up doing this is recursive. That way part 1 and part 2 work without really any issues or really any changes. The only difference is that part 2 I manually repeat the 5 times it needs. But for both of them, we go through, first parse it to get the sequence and then the pattern, or the number of each pound symbol. And then we go to this recursive. I do have a cache here to speed up the second part just a little bit. It doesn't do too much, but it does a little bit. But for the recursive, what we do is we first grab the current sum we are at, or I call them sums. We grab the current grouping number we are at. So if you're on the first one, it's 9, 1 second, 1's a third. Grab the one we are currently at, which is going to be index 0, and then calculate how much of characters are remaining in the pattern, excluding this one. So in this case, if we're at 9, that means we have 3 characters remaining at minimum, because again, you have 1 and 1, but you need a period between the 2 pound symbols, so there's a minimum of 3. And this is used to determine kind of the range that you can move your we can move the current sequence, or the current grouping of pound symbols in the string. So it's remaining, and then we also keep track of if this is the last grouping we're running, which simply just means that sums is empty now, or well, in this case is 1. And then we get to this for loop. So this for loop here is just in control of taking our current grouping and moving the grouping through the sequence to hit all of the different locations it can possibly be. Again, using remaining as the end stop of this is as far as you can go, because we have this many characters remaining at minimum. So we go from 0 to that with some logic here to adjust where the pattern is in the sequence. Our subsequence is, again, the sequence we're given if it's the last one. Otherwise, it's the substring of the sequence from the start of where we're at to the offset plus however many of the pound symbols we need, which is what this is. And then we also grab the test string, which is basically the built up of the reverse. Instead of it being all the ones remaining, it's all of the numbers we have gotten to with the or not all the ones we've gotten to, but the current one we are at. So we simply repeat the I however many times we are offsetting because of I. Repeat the pound symbol, our grouping number of times. And then also we need to repeat with at least 1 period as long as you're not on the last check, because because since all of the groups have to have a period between them, we need to make sure that this grouping there is a period after this grouping before we get to the next one. But from the last one, that's the only exception, is the very last grouping doesn't need a period after it, which is why we have the check here. What that means, though, is we have a test for the string validity. Assuming the string is valid, which means that this part is valid for the subsequence, we can then go through, and if it's the last one, we can simply just return, or we can actually increase our valid because there's no more recursion to check. Otherwise, there's recursion to check. Here's the cache stuff. Our key is just the current sequence with the current number. And then we can go and recurse it, and what we're recursing on is ignoring the current grouping, and then ignoring all of the characters that this grouping is covering given the offset, which is what this logic is, go ahead and recursively do this. So for this first example here for 9 and 1, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So in the very first task, so no offset, these are going to be these 9, and then including this 1 period for the ending of the group. It says, all right, these 4 use this subsequence and pass in these 2 1s, and find now all of the combinations that these 4 are valid for these groupings. And that's where the recursive bit comes in, is then, you know, these move around, but then also recursively called to this one with however much is remaining there. That's where the recursion comes in, and that's how it bubbles up, and we can return the valid there. So hopefully that made sense. Again, part 1 and part 2 with this method are the same. Just for part 2, you have to repeat the pattern and the groupings by 5. But yeah, hopefully that made sense. Again, this part was all kind of whack because my initial solution worked, but then doesn't work for part 2, and then I actually ended up rewriting it. So it kind of made this whole video very awkward to do. But anyways, hope you guys enjoyed. I'll see you guys all soon for day 13. Peace out.